This conference is brought to you by CodeStack, React and React Native development experts.
Hi, welcome, or Servus as we say in Bavaria here at React Native EU 2021 virtual conference. Thanks for having me again. My name is Alexander and I'm talking about animations today and how to use animations in React Native that they look beautiful, that they run smooth at 60 frames per second, even on low-end devices. So when we are talking about animations in React Native, we have to keep in mind that the general architecture of React Native can be quite challenging for running smooth animations. There are pretty good solutions out there. I want to talk about 3 of them today. And yeah, basically it's the 3 solutions we use regularly in our company when we are working with React Native applications. And I will give a short overview of all these 3 solutions. And I hope every one of you can take something out of this talk. So let's start right away. When we are talking about animations, the first question we have to answer is why are we using animations? Well, first of all, they make our apps look nice, but that's not the main reason. At least it shouldn't be. An animation should always serve any purpose. So at least they should increase the user experience. So for example, we could use an animation to give an advanced feedback for a touch interaction of the user. So when the user, for example, presses a button, which he has to press for at least 3 seconds to trigger any action, we could, for example, fill any bar that the user sees, okay, I have to press, and now the action's triggered. So this is an example which for what I mean when I say any animation should serve any purpose. Another thing is progress and loading indication. So it's always good to give the user anything he can look at while he's waiting for the content. So progress and loading indication is a good example for an animation or where animations should be used. Also, a lot of apps do use scroll animations at the moment, especially in the header area. So when we scroll, a larger header is scrolled out of sight and a smaller header occurs. And last but not least, animations are a great tool to grab and direct the user's attention to any part of the screen. So when something moves on the screen, the user looks at it. So animations are great for grabbing the user's attention. So basically, you could say animations are an important part of any high-quality app. And since we all want to write high-quality apps in React Native, we should have a look how to make great animations. And to understand how to make great animations, we have to understand the challenge with animations in React Native first. So what's the problem with animation in React Native? I think the part in the middle of the screen is something you all know. It's the general architecture of React Native. So we have this JS thread where we execute our written JS code. And then we have the native thread, which does all the rendering and gets the user interaction. And these threads communicate via this thing called the bridge. And this architecture is fine, but it can become quite a problem when dealing with animations, because when you look at the example on the left-hand side, this is basically an example like I described before. We have image as a header, And when we scroll, we slightly move the image and the title out of the scroll view, and a small header occurs which stays atop of the image. And when we overscroll, the image gets scaled. It's just normal behavior in an application or in a mobile app. So a lot of apps do this. So it's basically a pretty simple animation. And what's the problem with this simple animation? When you look on the right-hand side, here is described what happens under the hood when we work with the general React Native architecture. We get the on-scroll event and the value of the scroll view every 60 milliseconds, at least if we don't throttle it. And we shouldn't do so, because then the animation would look quite laggy. And every 16 milliseconds, we send the scroll view over the bridge, calculate the new values for our animated components, send these animated values or these values back to the native thread, where the native thread renders the view. So this can become quite a problem, because not every animation is that simple. So there could be some more calculation involved. And when we have a lot of calculation on the JS thread, in the worst case, our JS thread becomes blocked due to all this calculation. And this would mean, on the one hand, we are not able to directly handle any more user input. And on the other hand, it would possibly delay our animation, and we would drop some frames, which then would make the animation look very messy and not that smooth. So there are some solutions to this general problem. And as I said, I will show 3 of them today. But before we dive into the solutions, let me just introduce myself very briefly. My name is Alexander Kuttig. I founded my own software company here in Munich in 2012. I work with React Native since 2016. I also made some small contributions on community projects like Async Storage. By the way, it was a great experience. The guys there were very helpful. So if you never contributed to open source, I can definitely recommend it. So just give it a try, even if it's just a very small contribution. It could help us all. So yeah. Back to me, I'm also an AWS solution architect professional because I needed some knowledge for writing the backends for my app, and AWS is a great solution for that. And I'm also trying to write from time to time on my Medium blog, so if you'd like to, you can follow me there. I'm working at my own company. It's called Horizon Alpha. We are based in Munich. We are 32 people at the moment, and we focus on React and React Native development. And we build cloud-based backends for our React and React Native applications. We are working with AWS, Google Cloud, and Azure. So we're working with all 3 big cloud providers. Yeah, it's very, very good to work with the cloud providers for backends for our apps, because it makes it very easy. Back to the topic. When working with animations, at least when we work with animations in our company, for us, there are 3 ways to deal with animations. First one is the internal React Native Animated API, which does a good job for simple animations, and we like to work with it a lot. Second one is the great Lottie framework. There are SDKs for native integration, but also React Native Lottie SDK. So it's very simple to use, and I like it a lot. So if you have never heard of it, you will be really surprised how easy it is to integrate animations, smooth animations running at 60 FPS in React Native. And third of all, it's the awesome Reanimated framework, which recently was released in a second version. I love to work with it. If you have never worked with it, you should definitely have a look at it. I think I read in a blog post lately, it's the gold standard of animation, and I couldn't agree more. It's really awesome. But let's start with the internal Animated API. Here we see a very simple example, but it's good to explain how it works. I've taken this from the official React Native documentation, and as I say, it's very easy. So we have this view, which is declared as animated view. This basically means that we can use animated values in the styles of the view. So as you can see here, we have a general style, and then we have this additional style which gives an opacity value, and this opacity value is one animated value. It's called fade anim. It's just a variable which we define. We can name it like we want, and yeah, we give this value to the opacity. And then to complete what you see on the left side, we have these two buttons. It's the fade in and the fade out button, which calls the fade in and the fade out function. And this is how the declarations look like. So we have this fade anim variable, which basically we work with functional components here. So we store it as a reference, and basically it's an animated value which gets initialized with a 0. And then we have the fade in and fade out function, which uses the animated.timing to change this animated value. So we give the animated.timing the fade animated value and say, okay, please take this value and change it to 1 over the duration of 5 seconds. And what animated timing does is it calculates how the value should be in any frame in this 5 seconds, and then it renders the value, or it passes the value for every frame to native. So basically it's the same for the fade out function, except that we change the value to 0 and that the duration is only 3 seconds. So the fade out is faster than the fade in. Yeah, it's a very basic example, but I think it shows clearly how how animation works and how it is like to work with animated values, because basically all animation works with this animated values. So let's come back to our scroll example from the beginning. Basically, it's the same concept. We have this scrolling value here, and this scrolling value is changed, but it's not changed via an animated timing function, but it's changed due to the animated event function, which we use to kind of couple this scrolling value to the on-scroll event, to the native on-scroll event of the scroll view. So what we are doing is we look at the native event, which we get on scroll, and then we extract this y value and couple it to the scrolling animated value. What you can see here in the top is basically the image and the view, which is the small header which occurs. And basically, you can see here the opacity. It takes an interpolated small header opacity variable. We'll have a look at this later. And here we transform the image, right? So we translate it with an interpolated translate value, and we also have an interpolated scale value where we scale the x and y dimensions of the image. So where does these values come from? Basically, it's simple interpolation. We have the scrolling value, which is our animated value, like in the example before. But now, since we don't only want to use the scrolling value directly, because it goes from 0 to infinity, and we don't want to change any opacity to infinity, we do a simple interpolation. And this interpolate function works very well because we just say, okay, take the scrolling value, and we define an input range and we define an output range for this input range. So basically, when working with this interpolated small header opacity or calculating this interpolated small header opacity, we say, okay, from 0 to 200, please do nothing, stay at 0. And then when changing from 200 to 220, please change from 0 to 1. And what this interpolation does is it calculates the values for the different scroll positions and passes this to native. Same for scale and translate. So when we come back here, you can see this useNativeDriver true. And this really is a very, very important thing, because what this useNativeDriver does is it says, please take all this logic and pass it down to native in one call. So when we are working with useNativeDriver, we change the behavior of the animation from the one we've seen at the beginning to this one. We create the animation rules in our JS thread. We then send this animation rules to native, and the native thread then knows the animation rules, and all calculation and all rendering is done on the native thread. So we don't have this round trip every time on every frame or on every scroll event. We are processing our animation completely into native. And this is really awesome, because then we never block our JS thread. We can respond to user interaction. We can use our JS thread as we like. And yeah, that's why you definitely should use useNativeDriver when working with the Animated API. Well, here we have a little more advanced example. This is taken from an awesome YouTube tutorial from Catalin Miron. I think he spoke here 2 years ago. And as you can see, basically it's also a scroll view or a flat list in this example. And basically it works the same, right? We have this animated event where we have the scroll value. In this case, it's the X value because it's a horizontal scroll view. We also use the native driver. And what's the difference to the example before is that we have the interpolation not on one time in general, but we have the interpolation in every item. So for every item, we have an animated view which has its own interpolated value. And it's very cool because it shows that this useNativeDriver can create very performant animations, even if we have a lot of interpolation in play. And that's only the lower part of the screen here, right? There is some more code for the image in the background and the changing of the images in the background. But just have a look. I've put the expo snack of Catalin Miron here. Also, he has a lot more YouTube videos on his channel where he talks about using animation with the Animated API. So would definitely recommend it you'd like to see some more complex examples, please have a look at this YouTube channel. So summary for Animated. Basically, my tips are use useNativeDriver. I would recommend not to use Animated API without using useNativeDriver. Basically, it's just interpolating animated values. It works great with scroll view and flat list because then it's easy just to couple the scroll value to some animated value and then interpolate it. And it's best for simple and easy animations. So now we're coming straight to the limitations, because complex animations can become quite confusing. They can become a lot of code, and you are able to kind of combine animations. You can run animations in parallel, you can run animations one after another, and so on. But they become quite complex and quite confusing very fast. So we in our company use the Animated API for simple use cases and in applications where we only have these simple use cases. Another thing which you have to keep in mind, that useNativeDriver is limited to non-layout properties, and this is a very, very large limitation. So things like transform and opacity will work, but all flexbox and position properties will not. So you cannot just say, okay, please change the height with an animated value while using NativeDriver. So this won't work. So after the internal React Native animated solution, I want to show you a framework which I really like and which is the basis of this animation you see on the right. And this framework is called Lottie. So when you look at the animation on the right side, this animation would be quite a lot of code when we would have to script it with Animated or even Reanimated. So all these lines which occur one after another, it would be a lot of work. So that's where Lottie is the ideal library for. Basically, when you look at all these animations, all what they have in common is that they aren't that easy to script. But with Lottie, the code for them basically is all the same. It looks like this. You have a Lottie view and you have a JSON file, which is the resource for your animation. And this really is cool when you have the JSON files. I will show you now later where these JSON files come from. But basically, it's that easy, right? This is the code for all three of the applications, just with different JSON files. We have a container which we center our animation in. Then we have the Lottie view, and we say to the Lottie view, please autoplay, and then it just works. One thing which makes Lottie a lot cooler is that we do have programmatic control over the animation which is defined in the JSON file. So basically, as you can see here, we again have a scroll view where we couple the Y value of the onScroll event to our scrolling animated value, which is defined here. And then we have an interpolated progress, which we couple, or which we interpolate the scrolling to. And we just say, okay, please, for minus 1000 to 0, go from 1 to 0, and from 0 to 1000, go from 0 to 1. Basically, what we are doing is we use this interpolated progress to say the Lottie view, it should play on scroll. So when we scroll fast, the animation will play fast, and when we scroll slow, the animation will scroll slow. And as you again see, we are using native driver here. So all this takes place in the native or UI thread, and we don't block our JS thread. When you look at the animation here on the left side, you can see it does do nothing when it stays where it is. And when we use the scroll view, it starts animating. And this is really cool because we can have very complex animations in this JSON files, and we can control when it should play, where the progress should be, how fast it should play, and so on. So we have a lot of control over the animation. And where does these animation JSONs come from? Well, basically, they are After Effects animation files. So Adobe After Effects is a program which is used to create animations for videos and for other things. And then there is something called the Body Movement plugin, which creates these JSON files out of the After Effects animations. And this is really cool because when we come to the summary, there is quite a large market for these Lottie files. So there is this lottiefiles.com website, and it has a lot of animations, free animations, paid animations, and you can find animators there which create custom and cool animations in simply no time for your project, and you as a developer don't have to script your animations in your code. You can just work with a professional animator who creates the animation, and then you can use this animation via the Lottie React Native plugin. I put the link in here, and you have at least some control over the animation programmatically. And we use it for avatar animation, we use it for animations which have a lot of components, and we use it for animation where we don't have to be able to change all of the animation in our code, because that's one of the limitations. We don't have full control via code, right? We can say, okay, please play from frame 60 to frame 120, but we can't say, okay, this part of the animation is too large, please make it smaller. That has to be done in After Effects. So one of the limitations is you have no full control via code. The other limitation would be you need to create the animation files either by hiring a designer or animator, or do it yourself with After Effects. After this short introduction to Lottie, I want to talk about the awesome Reanimated 2 framework. It's the third framework we use when we are working with animations, and I think it's the most complete of all. So to understand what happens with Reanimated 2, I took some code from the documentation of the Software Mention page. It's basically, the idea behind Reanimated basically is kind of the same like useNativeDriver, but it's a lot more complete. So what they did while creating React Native animation, they introduced something called Worklets. And Worklets basically are parts of code which don't run on the JS thread, but it runs on the UI thread. It runs directly on the UI thread. So basically, you can simply put the worklet string in your function, and then when you work with React Native Reanimated, the Reanimated Babel plugin sees, okay, this is code which should be executed on the UI thread, and the Babel plugin transforms the code that is executed on the UI thread. So basically, this is what I just said, right? When we have this scroll view example from before, we have the JS thread where we create the animation rules or we create the worklets. And then we have the native UI animation thread where we have the worklet context. It has its own context on the UI thread. And basically, in this context, the calculation of the animation is done, but again, it's on the UI thread. And it gets even better. So we don't have to write our own worklets. So React Native Reanimated provides us a lot of custom hooks, which we can use to have it a lot simpler to work with Reanimated or with animated values or with code running on the UI thread, so we don't have to define by ourselves what is a worklet and what is not. So we can just have a style variable or a style constant, which we say, okay, use animated style, so make it an animated style, and then we can it runs on the UI thread. Another cool thing is that we can have shared values between our JS context and our JS thread and the native context or the worklet context, I would say. So what that means is when we're in the worklet context, we can synchronously change these shared values. And we are also able, from the JS context, to asynchronously change these values. This is due to the architecture, but it's really cool to be able to communicate from the JS context or JS thread to this native thread and also be able to synchronously change these shared values inside our worklets. So let's get this. Let's get the pieces together here. So again, we have the scroll view example, and as you can see here, we have a scroll value which is defined as use shared value and which is initialized with 0. And then we have the onScroll, which basically is a function which uses animated scroll handler, which is a part which React Native Reanimated provides us. And again, here we look at the onScroll event and we couple the Y scroll value to our scroll value. And when we are looking at now I have to go back once. Another cool thing you can see here is that we pass this animated scroll value down to our item component. So we have a lot of items in this scroll view. You can see it's the single items here. And basically, with the scroll value passed down to the item, we can work with this shared value in the item. And that's basically what we're doing here. So this is how the code of the item looks like. And you can see here we have a style here and we have a title style here. And basically the title style is the style of this text here. And the style is the style of the whole container. And when we go one slide further, here you can see how style and title style are calculated. And basically, it looks very similar to how the Animated API works like. We use this useAnimatedStyle hook, and then we return an object which includes a style, and basically we're using, again, simple interpolation here. So we are using the animated value which we got passed down to our component, and we say, okay, for this input we're using the index here, which we also got passed down to our component. For this index, to this index, or this value to this value, please change the size, the height of from minimal height to maximal height. I think it's 200 and 400 pixel here. And when you remember what I said about Animated was that Animated in a native context was limited to transforms and opacity, and we could not work with things like height. Well, the cool thing on Reanimated is here we can. So we are able to transform our flexbox values. When we're coming to the title style here, it's also a user animated style. Only thing is that we only change the opacity here. So as you can see, when we scroll up and down, the opacity of the text below the title here changes. So yeah, basically it's the same what we did in Animated, but in the Reanimated syntax. So this was a kind of a simple example. There are a lot more complex animation possible with Reanimated. There is this very, very cool YouTube channel of William Candillon. He is a magician when it comes to Reanimated and making animations. And on his YouTube channel, he has a series. It's called Can It Be Done in React Native, where he looks at the best animations from any app and builds them in React Native. And most of the time he's using Reanimated and Reanimated 2 now. So the animation you see on the left side here basically is a swiper where you can change the screen by swiping. But it tracks where you swipe and how fast you swipe and things like that. And I included it here just to give you an idea how complex this calculations of such an animation can be. And this part I pasted here on the slide is just a calculation for the wave animation here. So it's just a part of this liquid swipe example. I pasted the link to the full example here. So if you're interested in really cool Reanimated stuff, please check out the YouTube channel, check out the GitHub, which I pasted here. There are a lot of different examples, and you get a very good idea how powerful this Reanimated tool is. So to wrap Reanimated up, we in our company use it for complex animations. We use it we also use it for easy animations when we use it anywhere in our project, because we don't like to use Animated and Reanimated in the same project because it can get quite confusing. So when we have more complex animation and we integrate Reanimated into the project, we use it for all animations. And my tip definitely is watch the Can It Be Done in React Native series on YouTube. It's awesome. Limitations of Reanimated. Well, basically there are no real limitations except that it can take some time if we want to build really complex animations. So when we compare it to Lottie, where you can use After Effects to create your animations, this can be much faster than to write your animations in code. Well, the advantage in Reanimated is you have full control, but sometimes it's easier to just create the animation in After Effects, and you don't need that much control. Then Lottie is the better framework for me. And yeah, that's basically what I said at the last point. Animations have to be implemented by the developer. when you have a larger team where you have someone who really has a talent for cool animations, but he's not a developer, then Lottie is the better framework, because he or she can just build the animation in After Effects and then hand it over to the developer. Yeah, to wrap this up, I made this slide with useful links. I think I mentioned most of them. Animated has a very good documentation on the React Native page. I really like the YouTube channel of Catalin Miron. The Lottie library is available on GitHub, or the Lottie React Native plugin is available at GitHub, on GitHub. And on lottifies.com, there are a lot of files and animations for free, and there are also paid animations. So just have a look. Maybe you can find something cool there. Reanimated. There are very good documentation files on the Software Mention page. They also have some good webinars available there, so you should definitely check it out if you haven't done it already. And again, I can definitely recommend the YouTube channel of William Candillon. It's awesome, and the series Can It Be Done in React Native? It's really awesome. So I want to close my talk with a little quote. It's basically the same which I said at the beginning. Use animations where they improve the user experience of your app. Never use animations just because you think they are cool. So if you're that pumped after this talk now and say, I want to start using animations now, and go to lottifies.com, take the best animations, please keep in mind, don't use animations just because they are cool or if they make your app look great. They always should serve a purpose. So that's from my side. Thanks for listening. If you have any questions about the talk or any questions about React Native stuff in general, you can contact me via email or via my LinkedIn account. Thanks again for having me, and have a nice conference.